In this video, I'm going to show you how to insert a node by its index in a doubly linked list. Alright, so for this method, I'm going to call it insert. Insert will take in two arguments. First is the index, or in other words, the location within our list that we want to insert this new node. And then the second is the value. Alright, the value is going to be passed into the creation of a new node. All right, so first step is we're going to check if the index is out of bounds. All right, so if index is less than 0, or if the index is greater than this dot length, return undefined. Next, we're going to check if the index is 0. So if index is equal to 0, then we're going to call a method that we built out earlier, which was unshift, right? Unshift, the purpose of that method was to insert a new node into the beginning of a list. So all we have to do is make use of that method here. Our next step is, what if the index is the index for the end of the list? In that case, we do have a method for that as well, and that was the push method. All right, so if the index is equal to this dot length, so in other words, if the index here, so this right here is the length, so the length of this is 1, 2, 3, 4. So the index would have to be 5, right? Or in other words, pointing it would have to be 5 because we start 0 index, right? So this would be 0, 1, 2, 3, and then 4. So 4, the index of 4 would be pointing over here, which is equal to the length of this node, 1, 2, 3, 4. So in that case, it means that we have the position here to insert a new node, and we can do return this dot push. All right, so there we go. And next is we're going to set variables for previous node, current node, and the counter. So the previous node is going to start at null because this is going to be one position left of the current node, so to the left of it. So initially it starts at null, whereas the current node, as in the most cases we've been doing thus far, has been at the head because that is the beginning. And then we have the counter because we are going to be using a while loop. So this keeps track of the loops we make, and when we're checking for a condition, which I'll show you shortly. So currently the counter is at 0. So now that we set up the variables, now is the loop while the argument index is not equal to the counter. So this is where the counter is going to come in use, is for the condition within the while loop is checking if the index is not equal to the current counter value, then enter this block of code, which essentially all the logic, or what we're going to take of within this while loop, is updating the values, these values over here, or the variables here. So the first step is to update the previous node. We're going to update it by now making the new previous node become the current node. So this advances the pointer one position to the right, and then we update the current node to become the current node dot next. So this advances that pointer to the right as well, one position, and then finally update the counter by 1. And there you go. So at this point, the while loop will run until the index is equal to the counter, in which case we exit the while loop, and at that point, these two values, the current node and the previous node, will have the the nodes that we're gonna need to start setting up the pointers. Okay, so for instance, say I want to insert a node over here. So in other words, like let's say I call list dot insert, because it's called insert and it takes in 2 arguments. So in this case, this 0, 1, 2. So at index of 2, I want to push in a new node. So index of 2, and what's the value I want to push in? Say 150. Okay, so I want to push in 150 right over here. That is what I'm shooting for. Okay, so in this case, the while loop will advance our pointers, and what will happen is at the end of this while loop, once it finishes, then the previous node's value should end up being this 7 here, and this current node should end up being here, because that is going to allow us to start making these, setting up our pointers to point to, say, our new node, which again, it was 150, right? It was 150. So we would have to, instead of having a 7 point to 24 and vice versa, the 24 point is 7, we're going to have to start by making the 7 here, which is the previous node, to point to 150, and having the 150 point back to 7. And then at that point, once we take care of that, we're going to have the 24 point to 150, and then the 150 point back to 24. Now remember, we are having these pointers point in both directions because, again, this is a doubly linked list. In the singly linked list, we didn't have to do that because it was unidirectional, one direction. So now that is the additional steps that we have to take with the doubly linked list as opposed to the singly. We have to make sure that if we're using these pointers, that we have to also point it back to in the opposite direction. So that's why I say 7 is going to have to point to 150, and then 150 is going to have to point to 7, and then 24 is going to have to point to 150, and 150 point back to 24. Okay, so let's go ahead with the first step. As I mentioned, we're gonna start. Step 1 is to point 7 to 150. So the way we're gonna do that is, because currently the previous node is 7, we're gonna say previous node dot next will now point to the new node. So it's like as if this 7 was initially pointing to the 24. So we can essentially remove this pointer to 24 because now the 7 is pointing to the 150. I can't draw this line out, but just imagine that now that this 7 is now pointing to the 150 instead of the 24. All right, next step is having the 150 point back to the 7. So the way we do that is, again, this is the new node, and good thing I remembered is we still have to create that new node. So that's what I missed over here, and that's okay. So over here, right over here, right after, as soon as the while loop finishes, let's create that new node. New node equals new node, and pass in that value that we're getting as an argument. Value. So this statement here creates us our new node, which in this case example, it's 150. All right, so let's go ahead and continue. All right, so as I said, the next step is to have the 150 point back to the 7, or aka the previous node. So the way we're going to do that is have the new node's prev property now point to the previous node. All right, so this is the new node, and it has a previous property, which would point, it would be the arrow pointing to the left. So we want it to point here in this direction to the previous node. All right, so now this 150 is pointing back to the 17. All right, next step is to have this node, which is in this current node here, it currently holds this node here, which is 24. So we want the current node to point to 150. So the way we're going to do that is the current node dot prev, because we want the arrow here for the prev for the current node to point to 150 now. So to point to the new node. So at this point now, this 24, which is the current node, is no longer pointing, has the arrow pointing to the 7. So we can remove this arrow from there. And realistically, it's like this arrow from 24 is pointing to 150. And again, I can't draw this arrow for you right now, but just imagine that as it stands, there's an arrow that exists from 24 to 150. But again, because we are dealing with a doubly linked list, we have to point an arrow back from 150 to the 24. So that would be the final step here as far as setting up our pointers. So we're going to have the 150, which it's the new node, and have its pointer, which is next, to point to the current node. And that current node is this here. So now at this point, we have all of our pointers set up. So 7 is pointing to 150, 150 is pointing back to 7, and the 24 is pointing to 150, and 150 is pointing back to the 24. So if I remove this 150 from here and placed it over like this, 150, and it's now pointing, the 150 is now pointing to the 24. This is currently how it stands, because now we made that connection over here. All right, so the final step is to increment our count, the length, this dot length plus plus, because we are inserting a new node, therefore increase the length of the list, and then finally return this, or return the list. And there you go. So let's go ahead and test this out. So again, we were inserting, based off this method here, we're inserting at position 2 or index 2, so 0, 1, 2 over here. So it was, which was originally the 24. That's where we're inserting the node of 150. All right, so our list should end up like this. Let's go ahead and test this out. All right, if I run the code, previous, okay. All right, there's a typo error here that I made, or no, okay, there we go. So previous, not previous. All right, I'm gonna save that, rerun the code, and there you go. All right, so we get a length of 5, that's correct. All right, you see here, length of 5. Now let's go ahead and expand this. You see that the node is 2, which indeed it's 2. And what's to the right of 2? If we expand ahead, we see it's 7. Indeed 7. What's to the right of 7? If we expand that, we see it's a node of 150. 150. And what's to the right of 150? If we expand that, we see it's a node of 24. 24. And what's to the right of 24? It's a node of 75, which you see is 75. What's to the right of 75? It's null, which it's a tail. So of course it's null. And then at this node here, 75, it's going to go backwards. Because if you look here at its previous property, you see it has a node of 24. So it's pointing backwards now to 24. And the previous to the left of 24 is, if we expand the prev, is a node of 75. Oop. No, I'm sorry. Yeah, here. I highlighted the wrong one. So the prev is 150, which is this. And then I could continue on and on, but you can see that now it's working in 2 directions, pointing forward and backwards. So there you go. We were able to create a method that inserts a new node based on the index